For step 2, let's set up our refinery study. The optimization or the generation method we're going to use is optimization. The outputs that we're going to look at are the number of seats. We like to maximize those. We like to minimize the distance to the focal point, so kind of keep you as close as possible to the speaker or the game as that possible. And we're going to minimize the obstructed views. Now, in terms of the total number of variables, this whole notion of how wide the bottom row is, what the curvature is, what the bottom row length between the aisles is, the number of rows, the incline, those are all things we can, start playing with. Let's kind of think about what some sensible trade-offs might be. So in this amphitheater, if we had our choice, we could kind of take a look at the difference between, adding additional seats on the bottom row versus increasing the number of rows. We could still add seats, but we could do it by either, making the aisles a longer distance between. We could make the rows longer. We could change the curves. All these different things we could sort of work with together. So let's just go ahead and think if we can kind of construct some basic trade-off between, if we had the choice between, bottom row end, kind of changing that, or the curvature. The curvature, I don't think it'll make a difference there in my mind. I'm just trying to think of it practically. So bottom row end versus the aisle length. Now, how about that? Let's trade off the aisle length versus adding more rows. That might be sort of an interesting thing. So would I prefer to have more aisles trying to keep the same number of seats, and more rows, or would I prefer to have less aisles? Yeah, and kind of keep the seats closer. So, okay, let's see. That seems like a reasonable trade-off. I always try to plan my trade-off first. So let's go over and set up refinery. So I'm going to do a new study here. You see I've done some studies in the past just to kind of test this. I have an issue, and then I haven't saved. Let me save that. That'll take care of that. For my inputs, let's do the outputs first. I'm going to say that I want to maximize my number of seats and minimize the distance. And I want to minimize the obstructed views. Okay, that's going to be sort of a constant. Now let's think about what we're willing to trade off for each other. I'm going to ignore the curvature right now as a variable. The length between the aisles, I'm going to let that be one of the things that changes, and the number of rows I'm going to let change, but I'm going to keep the incline the same and the bottom row distance the same. Okay, so just changing a few different things just to give that a try and see if we can come up with some sort of understanding about really whether it's better to add rows or to somehow change the length between the aisles. So let's run that. Again, what I'm after here is, rather than varying 6 different variables at once where it'll be hard to isolate the impact, I'm trying to kind of think about something that I think is a trade-off and understand what that behavior is so I can focus on that one design issue before moving on to some other ones. Okay, it's going through and running the different test cases. We'll just let that go ahead and cook away generating those cases. And when we come back for our next step, we'll go ahead and take a look at the results of that. I'll probably go through and generate another analysis too, where we play around more with the issue of the incline and the distance in terms of thinking about, or maybe the curvature, thinking about the kind of obstructed views.